Work it, make it, do it, make sense.
Cool, thank you for coming to this talk about Git workflow strategies for technical debt management. My name is Raquel Pau, and you can find some stuff that I personally have built in walkmod.com. Just a few details about me. Currently, I'm working in the engineering and productivity team of Shifted. So our mission consists of creating tools to standardize the way that we work in different teams and make it as standard as possible. And for example, we are investing time on promoting good test practices across all the toilets like Google has performed in a past. Also, I'm a founder of Walkmod, that is a static code analysis tool. And I have almost 10 years of experience in Java because in the past I was working in companies to create NoSQL solutions. And I have been a speaker also in different conferences. This is my second time on DevOps. And also I'm the organizer of a local meetup that is called Legacy Code Rocks Barcelona, but it's a more global initiative that is called Legacy Code Rocks. So what is true is that software is everywhere. We can find it in our mobile phones or in our local servers, are also in our houses, right? But please raise your hand. How many times have those that sometimes have you ever worked with legacy code? Please. Good, cool. And which is the reason? Usually we think that legacy code comes from projects that has been started some years ago, but this is not the reality, in my opinion. The reality is that there are many initiatives, many projects that comes from a very basic idea and needs to be validated, but there are not enough checks to continue with the maintenance of that project, right? And these missing checks makes that for us, we feel like we cannot change it because we are not, we don't have enough confidence to ensure that after we deliver a new release, everything works properly. However, there are consequences, even if we don't change it. And you can see in that screen that recently, 2 years ago, French airport has real problems only to maintain a Windows 3.1 version. Okay? So even if we don't change software, we could have or experiment problems. We usually try to describe all those good practices that we have avoided to invest time in creating new features as technical debt. But in reality, there are several technical debt categories involved in the software development process. In my opinion, we can classify technical debt in 3 different categories. The most common technical debt is knowledge debt, because it's the lack of good programming practices, the lack of a good architecture, and also the lack of knowledge of those libraries or technologies that we are currently using in our projects. And this is the real problem that we usually define as technical debt. Okay? But the reality is that we also have some problems where we don't have enough test coverage. That is what we call testing debt. But also it includes when we have problems executing tests and they take so much time. Okay? And this is a consequence, or an indirect consequence, of having a bad architecture. And finally, infrastructure debt that includes all those automatic steps that we need to execute since the moment that we create a new commit until it is ready into production. And the necessary politics to undo the last changes until the system is correctly working. However, all these problems has a very clear solution that constantly is promoted over the social networks or blogs. And as we can see, continuous delivery that promotes having a specific pipeline to standardize how we create a new release contains the previous ones. Continuous inspection, which is an initiative that was promoted by SonarQube, which consists of analyzing the code quality of each contribution, and also continuous iteration, because during the continuous delivery process, we need to ensure that there are automated tests and they are executed, right? And which is the common factor about all these good practices? And a specific Git workflow. Because feature branch workflow promotes to create new branches for new features or even bug fixings. And the main goal is to maintain a real clean branch, that is the master branch, and avoid collateral branches to maintain. And why? Because if we try to release after a while, when we try to deliver our software into production, maybe it's too late to understand if something has failed, why it has failed. Okay? And then, as a conclusion, this workflow promotes to have always little contributions, as much little as possible, because our main purpose is, after a failure, being able to understand why as fast as possible. So this is a common good practice in code reviews that always they recommend to use little patches. In fact, one personal experience that I have had is that after, for example, formatting all the source code of a project according to their own code style conventions, they didn't accept my patch. Okay? But ironically, it is correct, that patch. But which is the real reason about this? They cannot ensure that I'm saying the truth, that I haven't modified anything else. So having short contributions make code review faster, and also, in case of having a failure, I insist, we are able to understand why more in a fast way. So continuous delivery, as a practice, ensures that we are able to create releases faster, sooner, and finally, better. And which is the main challenge? We need to be able to orchestrate all the build steps until we have a new contribution, until it is at the end in the production environment, in order to validate our ideas or validate the business value that the new contributions are performing, right? This is an example of continuous delivery pipeline, where we receive a commit, so we need to define how we can receive the last contributions, how we can create a build, test it, and create artifacts to finally deploy them to production. And notice, which is the main purpose of this, having real feedback as fast as possible. So working in a clean way is not opposite to create software faster. And this is the main reason that we need to argue when we create software, and the manager or technical or business people don't understand why. And which is the most recommended way to implement continuous delivery? Well, in the previous statistics that Rebel Labs performed, the most common solution was Jenkins. And the next one are the no solution, right? So the next of the talk, we will continue explaining how can we implement continuous delivery with the new version of Jenkins. Because Jenkins, it's, as you know, an open source solution. You can contribute on it. But also, for this reason, there are lots of integrations already available that you can easily use, and probably your technology stack is among them. But which is the real problem that we have experimented in Jenkins if we want to work with a microservice architecture and we need to scale our projects continuously? Well, Jenkins has a visual interface, right? Or at least originally. And we need to create or build process as a script sentence. If we are in the world of microservices, this is a problem, right? Because what we consider a monolith as an enterprise system needs to be split into multiple projects. And the problem is that we need to create manually a Jenkins configuration for each of that microservices. And what happens if we need to change it? And which is the most important problem? What if we are not the maintainers of this continuous delivery process? It becomes even more hard. So the solution consists of avoiding this step from a visual interface and using pipelines as code, which is also renamed as infrastructure as code, that you probably know. And with Jenkins 2, this is the main feature that they suggest. And one of the main contributions that you need to realize is that the Jenkins pipeline systems allows us to create our own Jenkins libraries to use inside the pipelines. And it makes us to reuse the same release process across different microservices, right? So now the Jenkins configuration has been simplified because we also need to indicate that we will use a Jenkins file for a given project repository. But what contains that Jenkins file only appears in the repository. And we can have multiple configurations for all our branches because it belongs to Git. And this is one example of this Jenkins pipeline, where here we are setting that for all our Jenkins cluster, any of the machines that compose the cluster can execute it. And all the steps that contains our continuous delivery process are called stages. And we can define the set of steps that we want to execute at this stage that has a specific meaning. And finally, we also can define a post-process after the steps has been executed. This is the real part and the most simple way of using Jenkins files. But look at this. We also are able to have our own Docker images to create our built environment and reuse that from Jenkins with a Docker tag. So this build is run inside this Docker image that contains a very lightweight Maven version. Or even more, we are able to modify, redefine, which is the process that we want to execute in case of failure, of build failures, or asking for feedback, which is really valuable for many solutions like I will present you afterwards. And how has changed the Jenkins configuration? Well, right now we just need to indicate our repository here and say where is our Jenkins file. That in that case is in the root directory of the project. Cool. We have one methodology and tool to implement continuous delivery and share this configuration across teams. Okay? But in the case of microservices, it's well known that you don't need more people than those that you can feed up with 2 pizzas. And in that, if it's not true, that we have a problem then. But then we need to be agile in order to create new microservices constantly. And all these microservices needs to be created and maintained with a similar or equivalent technology stack. How can automate this part? Red Hat has a solution that is called Fabricate that tries to be a common development platform with wizards. It's really simple to use it, but it's in a beta state right now, and allows to have templates for each of the technology stack that we want to maintain. So in case, for example, of Maven or Gradle project, it creates a microservice hello world, and directly it deploys it to Kubernetes. So you don't need to configure anything else, because it also configures Jenkins, configures our Git repository, GitHub, or by default Gox. That is an open source solution too. And finally, it deploys directly to Kubernetes, so we don't need to learn how to configure anything. And all the teams share the same configuration. That's a good point. But what happens when we have several teams across the world, distributed teams, and all of them have a different culture about what is good code or their standards? It's hard to share these conventions across the teams, and sometimes they are not respected. And when we try to maintain a project that has been started from one team from another, we realize sometimes that we have technical debt. And probably this is too late. In order to control technical debt, what I suppose that you agree with me is that we need tools and metrics, because otherwise we only have opinions. And for Java, the most common tools to control technical debt that you probably know are static code analysis tools. One of them is PMD, that takes source code analysis and produces what are the code smells. Findbugs, that uses bytecode and reports to you what are the potential bugs that your code has. And checkstyle, which is focused mainly on formatting issues. Finally, we have SonarQube, that initially started with an integration of all of them, but right now is directed to create or maintain their own rules. And which continuous inspection in detail. I have said that this is a practice that was promoted by SonarQube because they think that the most important point is to control that you are not increasing your debt, because we don't have time to invest fixing debt that maybe they are not maintained anymore. So focus on what you are investing right now, your time, and make it as clean as possible. And how it works. In the context of a feature branch workflow, we apply checks during our build. Okay? These checks could be with SonarQube, but also we can use PMD or whatever. It doesn't matter. And if one issue is retrieved and reported by Jenkins during the build, we need to work a little bit more and fix it with a new commit. After, this is cool because we can control what we are doing, but what happens when we have hard deadlines? We usually remove this step because we don't want to spend time fixing dead code, probably, because it's not relevant enough to make our software better or working. But after a while, that we realize that we have some technical debt beyond that, and we run SonarQube, for example, we have several hundred of days of work to work with and improve what this code does. But, and this is a real screen about Struts 2, that it's a common framework. But there are good news here. And the good news are that most of these coding style violations could be fixable in an automatic way, because there are only one solution for those errors. And this is what we have done with Walkmod, that it's open source. And you can integrate it easily with Maven or Gradle. And running these tasks, you will get a patch that is a diff about those fixings that you can freely apply with Git directly into your repository. So you can review if it looks good for you and then apply it. And for example, for this little microservice that contains some dead code, in this case, an import and also a private attribute that is not used anymore because the software evolves, Walkmod has removed this. And also, according to our PMD rules, we have said that we want that all those parameters that are not modified, please make them final. And for those conditions that can be rewritten in a single sentence, please do this. But, OK, we can run Walkmod for those static code analysis violations. But why? What if we want to run our own code fixings, because there are many possibilities to fix a specific problem, and we want to do by ourselves in an automatic way? Internally, Walkmod is running a chain of code transformations. Okay? And the common task that we run from our favorite ADI is to clean imports, right? And how can it express it with Walkmod? With 3 lines of code. And it's really easy because Walkmod allows to resolve what are the definitions and the references that contains that piece of code, and also the specific type of all of them. And most importantly, after representing our changes in a logical way, when we dump these changes into our source code, it respects our previous formatting style. Please raise your hand if you have any question in some moment. OK, so there are common discussion about fixing tools because, well, Walkmod is for Java, OK, but there are other similar tools like Walkmod for other programming languages, like PHP. And for those tools, there are a common discussion about if we can trust in them or not. For me, the solution or the answer about this discussion is you always need to ensure test coverage in your project. So if this tool changes your code, it should work afterwards. But in case of not having enough test coverage, well, this tool should have test coverage. But you can decide if you want to trust in a tool that has test coverage or in a human. OK, so we have seen that we can run Walkmod as a plain Maven or Gradle task. And which are the next steps? Are really transparent. We just need to apply this patch that has been generated by Walkmod, walkmod.patch, with Git. Try if our tests are working. And finally, we are creating a new commit. And most importantly, we are using a specific git commit flag option that is fixup, which creates a new commit with the same message using the fixup prefix. And it is a common convention that Git implements to use this kind of to apply this kind of commits. And finally, we just update our remote repository. So then we can talk about continuous fixing, right? Because we can use Jenkins to run this previous receipt as a part of our build, and then if our initial build fails because the Jenkins says, OK, you have some coding style violations, you apply Walkmod, but breaks the commit, but breaks the build, creating a new commit, and if we run Jenkins again, we have a green status. And how the pipeline looks like? Well, there is an open source library for Jenkins that contains an Walkmod API that you can easily integrate in your build process. Remember, you can define your own library to standardize how you want to deploy or create a new release in Jenkins across different microservices. So in that case, we have created one example running Walkmod, and you can decide if you want to check the patch before submitting or applying directly into Jenkins. And also, we can define the branch that you want to use. By default, these are the values, and the branch is the current branch that it's going to be analyzed. Okay. Walkmod apply, it's one of the tasks that you can run with this library, but runs all the workflow that consists of checking if there are changes, ask for your feedback, and if you agree, push the changes, and breaks the build. But you can also redefine this workflow as you want, using internal tasks that do part of this process. So let's see this with a real demo. This is my Jenkins configuration for a microservice that I have in Gox, that it's an open source tool, very similar to GitHub. And it is prepared to run without internet. So then we just need to add here the repository as I have described, and also say here we need the Jenkins file. And if we check in our repository, we have a Maven descriptor that uses our Walkmod plugin. And in our Jenkins file, we are using Walkmod. And in this case, we are checking PMD conventions because we have the configuration there. And afterwards, we check PMD again. Why? Because maybe there are other rules that cannot be fixable by Walkmod, right? If there is a lack of documentation, Walkmod cannot create it for you. Okay. And our rule set, in this case, are in conditional if statements, collapsible if statements, that is the previous if simplification, and that code, and also for final members of the method. Okay. So with Jenkins 2, we can also have a more modern interface that is the blue ocean. And now, if I run the build, these are the common steps. Now we are running Walkmod. Okay. And also, if we want to check using the previous visualization, we also can do that. And we can see the same thing. And then, in this case, are asking for our feedback, and here is the patch that Walkmod has applied. Okay. So if we continue, you will see that the build will fail because it forces to create a new build to ensure that the new commit is working. And then this same thing. And if we rerun again, the same step is executed. But in this case, the patch will not be produced, and then after checking PMD, it will pass the build. We are running Maven package to run the tests. And OK, now it's green. Cool. And most importantly, if we go back to the old visualization and we analyze the previous build, we can see which is the patch that has been applied in a nice way, because there is installed the HTML plugin for Jenkins. But now the question that is arised is how if we need to create an incremental execution, because it works fine if we are creating code from scratch, because it's changing everything that has a code violation in there. So in the context of microservices, it's cool to use that workflow, but what about legacy code? If we have a monolithic application, and we run Walkmod, we will get a very big patch. And we are not able to validate that patch. And we maybe don't have enough confidence to validate this. For this reason, there is an alternative project that is called Walkmod Hub, very similar to SonarQube, that allows you to analyze fixing by fixing. And you can download that patch and apply it. We also have some productivity metrics to understand who is fixing some coding style issues, who are producing issues, and how the team is evolving during the time. And finally, we have the whole commit history to understand how the depth is increasing or decreasing over the time. As a summary, we have been that the problem of technical debt consists of having fear of changing features that was already implemented without enough test coverage, maybe, and their code is not good enough, well written. We have seen that the main issue that we need to attack is how we can define or release process in a declarative way without using visual interfaces. Finally, we have defined this release process using Jenkins pipeline, and these are part of our Git repository, and now we can see the history of our build configuration. We have seen also Fabricate as a solution for our development process to maintain the same technology standards for microservices. And we have seen a new workflow that is for continuous fixing, to apply changes directly into our repository and not spending so much time fixing coding style violations manually. And finally, we have seen that for legacy code applications, we need to do this in an incremental way to make sure that it works, and there is Walkmod Hub that can do that for you. If you have questions and answers, questions, so please tell me. Yes?
Does Walkmod apply only Walkmod rules or other rules of check style, find bugs, or anything else?
Walkmod can be configured for check style, PMD, or SonarQube, whatever. So it uses your PMD. It detects if you are using PMD, check style, or SonarQube, and applies those rules for you, the fixing for those rules for you. Are you users of Jenkins too? How many of you? Are you familiar with Jenkins file, I think? Cool. OK, so that's all from my side. And if you have any questions in the future, just contact me. I hope that you have enjoyed.